All right. So let's talk about voting. So we're going to finish up the course with a couple of lectures about voting, different voting methods, and sort of the benefits and drawbacks of each of them. So the first one is the one that you're most familiar with. It's just the popular vote, and we call that the plurality method. So the I'm going to have a hard time saying that. The plurality method of determining the winner of an election is that the person earning the most votes is the winner. So, for example, a group of 33 students have organized a political action committee on campus called the Environmental Action Council, EAC, to address important environmental issues. As a first step, they held an election to choose their president. The results of this election are as follows, right? So Anne got 10 votes, Ben got 9, Kareem got 11, and Doreen got 3. Using the plurality method, who is the winner of this election? Well, obviously it's Kareem, right? Kareem got the most number of votes. So that's the plurality method. It's really pretty simple. The next one is called the Borda count method. So looking back at the previous example, you may note that Kareem only got 33% of the vote, right? There were 33 students who voted, and Kareem only got 11 votes. 11 out of 33 is not 33%. Oh yeah, 33%. It's a third of the votes, right? So that's not great, first of all. But more importantly is this: suppose that Kareem was a polarizing figure, but that Anne was the second choice for a lot of people. So maybe 33% of people really loved Kareem, but 67% of people hated him, right? So the 11 that voted for him loved him, and the other 22 hated him. But he's their president because he got the most number of votes. Meanwhile, everyone kind of likes Anne, right? So she's like second place for a lot of people. So maybe you could argue, and you could also argue against this, but maybe a better outcome would have been for Anne to have won, right? So the problem is that plurality voting doesn't give a way to indicate your second, third, and fourth choices and so forth, right? So the Borda count gives us a way to do that. So in the Borda count method, the Borda count method permits a voter to designate first, second, third, etc. preferences. If there are k candidates in an election, each voter ranks all candidates on the ballot, and then the first choice is given k points, the second choice is given k minus 1 points, the third choice is given k minus 2 points, and so on. And then the candidate who receives the most total points wins the election. Okay, so to use the Borda count method on example 1, each voter casts what's called a preference ballot, which looks like this. And here I'm just using the first initial of each name. So this particular person voted for Ben for their first choice, Anne for their second choice, Kareem for their third choice, and Doreen for their fourth choice, right? So I'm just using the names A, B, C, D. Okay, so this is called a preference ballot. So just to be clear, this is just one ballot. This is just one person's vote, right? But they're ranking all four individuals. So then everybody who participates in the election casts a similar ballot. And then what we do with that when we're trying to count the votes is that we group together ballots that look the same. And we call that a preference table, right? So with 33 voters, some preference ballots are going to look the same. In fact, there are 4 factorial, in other words, 24 possible permutations of first, second, third, and fourth. So at most, there's only 24 possibilities. So if you have 33 ballots, then some of them are bound to repeat. Okay. In this case, we only had 1, 2, 3, 4, 5, 6 different kinds of ballots that were cast. So this ballot, which ranked Kareem first, Anne second, Ben third, and Doreen fourth, 6 people cast that identical ballot. 7 people cast this identical ballot. 5 people cast this identical ballot, and so forth, right? So assume that what was this? The Environmental Action Committee, I think, is what it was. So assume that the Environmental Action Committee from example 1 used the Borda count method to determine its president. You'll notice that this lines up actually with the results of the election, since Kareem here, you can see, had 6 votes for first place plus 5 votes for first place, so he had 11 votes for first place. Anne had 10, right? Ben had 9 and Doreen had 3. But the nice thing about the board account method is that you don't just cast your first choice, you also cast your second, third, and fourth choices. So you rank all of the things. So assume that they used the board account method to determine the president, and that the results are in this table here, are in this preference table. Now, who's the winner of the election? So if we were just using the simple majority like we did in the first example, it would be Kareem. But if we use board account, who's going to be the winner? Let's see. Well, what we need to do is count up the number of points that each individual earned. And I'm just going to do this in order. So I'm going to make a little table in order to organize my work. Okay, so for candidates, we're going to have Anne, Ben, Kareem, and Doreen. Each of the candidates is going to be ranked first place on some of the ballots. Sometimes they're going to be ranked second, sometimes third, and sometimes fourth. But then ultimately, we want to know their total number of points. So I'm going to create a column for the total number of points that they earned. Okay. So for Anne, she got first place 7 times and then 3 more times. So in total, she got first place 10 times. Okay. And each of those first place votes is worth 4 points. Okay, because there are 4 people running. So the first place gets 4 points, second place gets 3 points, third place gets 2 points, and fourth place gets 1 point. So Anne in total gets 10 times 4 points. For all of her first place wins. For her second place wins, she got second place 6 times, plus 9 times, plus 3 times. So 6 plus 9 is 15, plus 3 is 18. So she got, whoops, not there. She got second place 18 times, and she earned 3 points. She earns 3 points for each of the second place wins. So 18 times 3 is, oh goodness, 18 times 3, 54 maybe? Let me see. Yep, 54. So she gets 54 points for all of her second place votes. For third place, let's see. She never won third place. So 0 times 2 is 0 points for her third place. And then for fourth place, she got fourth place 5 times. And each of those is worth 1 point. So then her total number of points that she won is going to be 40 plus 54 plus 0 plus 5. And that comes out to 99. Okay, so then we're going to repeat this for Ben, Kareem, and Doreen. So for Ben, he earned first place 9 times. Each of those votes is worth 4 points, so that's 36 points. He earned second place 0 times. He earned third place, a bunch of times. 1, so 6 plus 7 plus 5 plus 3. 6 plus 7 plus 5 plus 3 is 21 times. He earned third place 21 times. Each of those third place wins is worth 2 points. So that comes out to 42 points. And then he won fifth place 3 times, right? 3 times. So that would be 3 times 1, which is 3. His total points would be 36 plus 0 plus 42 plus 3. That comes out to 81. Okay, Kareem. Kareem won first place 11 times. Each of those first place wins is worth 4 points. Okay, he won second place 7 times. That's worth 3 points each. He won third place 3 times. Those are worth 2 points each. And then he won fourth place 3 plus 9, so 12 times. And so his total number of points would be 44 plus 21 plus 6 plus 12. And that equals 83. And then finally, Doreen. Doreen won first place 3 times. She won second place 5 plus 3, so that's 8 times. She won third place 9 times. And she won fourth place 6 plus 7, 13 times. So her total number of points, 12 plus 24 plus 18 plus 13, is 67. Okay, so who's the winner of the election? That would be Anne, right? Anne wins, actually by quite a large margin, right? So Anne wins. Okay, so that's the board account method. Okay, so it kind of solves the problem of, if you have a very polarizing figure, maybe the person who won the second or the third number of first place votes can still win the election if they were almost everybody's second choice, right? Anyway. For your information, right, this process may seem a little bit strange, but for your information, it is used in a lot of things, like in the ranking of college football teams, for example. They use a board account for that. So anyway, moving on. The next method is called the plurality with elimination method. So remember, the plurality method was the first one that we talked about. It was just simple. Whoever had the most votes would win the election. Plurality with elimination works a little differently. So another way that we could potentially end up with a better outcome in the Environmental Action Committee example would be to eliminate the person receiving the least number of votes and then hold a new election. Okay? And that's the plurality with elimination method. So in the plurality with elimination method, each voter votes for one candidate. If any candidate receives more than 50% of the votes, then that candidate is declared the winner. Otherwise, the candidate or the candidates with the fewest number of votes is dropped from the ballot and a new election is held. This process continues until a candidate receives a majority of the votes, and majority means more than 50%. Okay? So in the case where we have 4 people running, it's like you'd hold your initial election. Whoever gets last place is taken off. Then you hold another election with the 3 people remaining. And then after the results of that election, you get rid of the 3rd place person. And then you hold a new election just with the top 2 finishers. And then whoever wins that election wins the whole thing. So you can see that would require you to hold 3 elections. If you only had 4 people running, you would still have to hold 3 elections. So in order to avoid having too many rounds of voting, we can simplify the elimination process by having each voter rank the candidates, just as we did with the board account method. But we're going to use the preference table differently than we did with the board account method. So to give you an example of that, let's determine the winner of the Environmental Action Committee election using the plurality with elimination method. This was the preference table. So it's the same preference table as we used for the board account, but this time we're going to use the plurality with elimination method. So in order to do that, the first thing that we do is we try to determine if any of the candidates have a majority already, right? So in this case, Kareem has 11 votes, Anne has 10, Ben has 9, and Doreen has 3. We're just looking at the first place votes, right? So Kareem has more votes than anybody else, but that's still only 11 out of 33, which is 33%. So nobody has the majority, right? Nobody has more than 50% of the vote. So that means that we need to eliminate the person with the least number of votes, which in this case was Doreen, right? Doreen only had 3 votes. So we're going to cross her off. And actually, we're going to cross her off everywhere that she appears in the table. And then we're going to make a new table where we just pretend that anything under D gets slid up, right? So we get a new table. In fact, we don't really need to write out the whole thing. 6, 7, 5, 3, 9, 3. And this first column is going to look the same, C, A, B. So is the second one, A, C, B. The third one, though, we're going to pretend that the D doesn't exist. So it's going to be C, B, A. The next one's going to be A, B, C. The next one's going to be B, A, C. And the last one's going to be A, C, B. So everything just gets shifted up, right? We just cross off the D's and then shift everything up so that we now have 3 rows instead of 4. And now we repeat. So we see, well, who has the most number of votes now? Well, you notice that we got rid of D, and what took D's place in this last column is A. So now C has the same number of votes as before, right? 6 plus 5 is 11. But A has 7 plus 3 plus 3. That's 7 plus 3 is 10, plus 3 more is 13. So, and then B still has 9. But A has 13. So up here, right? C had 11. A had 10. B had 9. And D had 3. Now, so we eliminated D. Now, C still has 11, but A has 13, and B still has 9. So A took the cake there. But notice that 13 out of 33 is still not a majority. It's still not a majority, right? 13 out of 33 is about 39%, right? So not a majority. So that means we need to eliminate another candidate. And again, we're going to eliminate the one with the least number of votes, which would be B in this case. So we eliminate B here, 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 and here. And then we make a new chart. So okay, so it's going to be C, A, C, C, A, C. Obviously, a lot of these things are the same, but that's okay. Okay? Well, so now what do we have? Now we have Kareem still has 11 votes, right? But Anne has 7 plus 3 plus 9 plus 3. That's 10. Plus 9 is 19, plus 3 more is 21. That's definitely the majority, right? That's definitely more than half. So Anne wins. Right? So it's interesting. So here we have an election where, again, if we do just a simple plurality, Kareem would have won. But if we do plurality with elimination, in other words, if we keep eliminating the last place winner and then have people go head-to-head. Like notice in this last election, right? When Anne goes head-to-head with Kareem, Anne wins. It's only when they all 4 run together that Kareem gets a lead because there are other candidates that sort of draw votes away from Anne. But it seems like, Anne's probably a better candidate, at least according to the board account and according to the plurality with elimination. So anyway, so that's how plurality with elimination works. One more voting method. It's called the pairwise comparison method. And the elimination method, the plurality with elimination method that we saw on the previous page, sort of gives rise to this idea that it's natural to expect that the winner of an election should be capable of beating each of the other candidates head to head. Okay? So in the pairwise comparison method, voters rank all candidates. If A and B are a pair of candidates, we count how many voters prefer A to B, and vice versa. Whichever candidate is preferred the most receives 1 point. If A and B are tied, then each receives half a point. We do this comparison, assigning points for each pair of candidates, and at the end, the candidate receiving the most points is the winner. Okay. So for example, let's determine the winner of the Environmental Action Committee election using the pairwise comparison method. Here was the preference table. Okay? So what we need to do is compare A to B. So we need to compare A to B. We need to compare A and C. We need to compare A and D. But then we also need to compare B and C, B and D, and then we also need to compare C and D. So we have 6 comparisons that we need to make. And basically what we're looking for is, if A and B ran head-to-head, who would be the winner? If A and C ran head-to-head, who would be the winner? If B and D ran head-to-head, who would be the winner? So we can determine that by looking at the preference table here. So what we're going to do is we're going to look at, for comparing A and B, we're going to look at all of the columns where A was ranked above B, right? And those count in A's favor. And then we're going to look at the columns where B ranked above A, and those count in B's favor. So here A comes before B. So this, maybe I'll use a pencil so that I can erase. So here A comes before B, so this column goes to A. Here A comes before B, so this column goes to A. Here B comes before A, so this column goes to B. A before B, B before A before B. Okay. Now, so A wins 6 plus 7 plus 3 plus 3 times. So let's see. 6 plus 7 plus 3 plus 3 is 19. So A gets 19, and B gets 5 plus 9, which is 14. That means A is the winner in that head-to-head race. So A gets 1 point. If we do the same thing for A and C, okay, C gets this column, A gets this one, C gets this one, A gets this one, A gets this one, and A gets this one. So in total, C gets 11 points, and A gets the other 22 points, I suppose, 7 plus 3 plus 9 plus 3. So A gets 22, and C gets 11. That means A wins in this head-to-head race. If we compare A and D, A gets this column, A gets this column, D gets this column, A gets this column, A gets this column, and D gets this column. So A has, in this case, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 votes, and D gets only 8, right? 5 plus 3. So again, A wins in this head-to-head matching. So right now we could stop doing our work, because we already know that in each of these head-to-head races, A is the winner, right? So even if B is the winner in both of these, B can't be the winner here, right? Like, none of them can get more votes than A at this point. None of them can win more head-to-head races than A. So A is obviously the winner. But I'm gonna finish this out though, just so that you can see how the process works, and then I'll give you another example of this one. So if we compare B and C, C gets this one, C gets this one, C gets this one, B gets this one, B gets this one, and C gets this one. So it looks like B gets 12 votes, and C gets 13, 18, 21. So C is the winner in that head-to-head pairing. If we compare B and D, here B wins, B wins, D wins, D wins, B wins, D wins. So B gets 13 plus 9 is 21. And C gets, or D gets 8, 9, 10, 11. Oh, I must have miscounted then. 13, is 22. Sorry. And then D gets 11. So obviously B wins in that head-to-head matching. And then finally, if we compare C and D, C wins, C wins, C wins, D, D, and D. So C gets 13 plus 5 is 18, and D gets 9, 10, 11, 12, 13, 14, 15. So that's the closest race so far, but C takes it. Anyway, so the winner here, so notice that if I make a little table, right, candidate and points, candidate A gets 3 points because they would win 3 of the head-to-head races. Candidate B gets 1 point, candidate C gets 2 points, and candidate D gets 0 points. So A is the winner, right? So Anne is the winner. Okay. So only if you do the plurality method, right, the very first one, does Kareem win. In the other 3 cases, Anne comes out on top. So that's kind of interesting. Okay. Let me give you another example of this, because because there's this little thing about, like, if they're tied, then each receives half a point, and that's maybe a little confusing. So I wanted to give you an example of something where that actually happens. So this says, in order to decide which item to add to its menu, Taco Bell did a market survey in which customers were asked to rank their preferences for tacos, nachos, burritos, tacos, nachos, and burritos. Okay, so just those 3. So the chain will use the pairwise comparison method to decide which item to add to its menu. The results of the counting ballots are shown below. Which item should the chain select? Ooh, they had a bunch of people in their survey. Well, that's all right. Okay, so what do we need to compare? We need to compare tacos and nachos. We need to compare tacos and burritos. And we need to compare nachos and burritos. And those are in this case, there are only 3 comparisons to make. So comparing tacos and nachos, so here tacos would take the win. Tacos would take the win. Here nachos would. Nachos. Here tacos would. And here nachos would. So tacos would get how many votes? 2,108 plus 864 plus 1,587. That would be 4,559. Nachos would get 1,156 plus 1,461 plus 1,080. And that comes out to 3,697. Okay, so tacos win that head-to-head election. What if we compare tacos and burritos? So here, tacos would get it, tacos would get it, tacos would get it. Burritos would get it. Burritos would get this one, and burritos would get this one. So tacos win the first three, burritos win the last three. Let's see. So how many votes does tacos get? They get 2,108 plus 864 plus 1,156. And that comes out to 4,128. What about burritos? They would get 1,461 plus 1,587 plus 1,080. And that comes out, wouldn't you know it, that comes out to 4,128. Okay, so who wins in that head-to-head race? Well, neither of them. It's a tie, right? It's a tie. So they'll each get half a point. All right. And then finally, we would compare nachos and burritos. So here, nachos win. Here, burritos win. Nachos, nachos, burritos, burritos. Okay. So who's the winner? So nachos are going to get 2,108 plus 1,156 plus 1,461. So that's 4,725. Pretty sure they're the winner. Burritos would get 864 plus 1,587 plus 1,080. That's 3,531. Okay, so nachos get the win there. So when we're making our little table, so candidate and points. So taco gets a point here, and it gets half a point here. So tacos have 1.5 points. Okay. Nachos get 0 points there, 0 points there. They get 1 point there. So nachos get 1 point here. And burritos get 0 points here. They get half a point here and 0 points here. So burritos get half a point. Okay, so the winner is tacos, right? So which item should the chain select? Taco Bell should, I guess, sell more tacos, put more tacos on the menu, whatever. Okay, so tacos are the winner. Okay, so that's how the pairwise comparison method works. In the next lecture, we'll talk about sort of the benefits and drawbacks of each of these voting methods.